Warm greetings, dear friends. Today we are going to see about the course on solid mechanics in the topic of bending stress. Before that, what is called as the bending moment and what is called as shear force and what is the theorem which is used to find the pure bending equations. So the bending moment is nothing but the product of the force and the perpendicular distance. So bending moment is denoted by capital M is equal to force F into the distance, perpendicular distance is D. So F into D. So the moment is having the convention of either clockwise moment or the anti-clockwise moment. So the unit of bending moment is kilonewton meter or Newton millimeter. Then in the case of the shear force, the transfer force which is on the beam will be considered as the reaction, so which is called as a constraint, the algebraic summation of all the forces either to the left hand side of the section of any beam or to the right hand side of the any beam, which is called as the shear force. So shear force is denoted by the letter capital F or capital S. The unit of shear force is kilonewton or Newton. Then what is called as the pure bending equation or bending theory. So if you take any beam which is having a symmetrical 2-point load on a simply supported beam, so which is of capital W on the either side of the support, and the total length of the beam is L, and the distance between the point load and any support, either left support or to the right support, is small a, so which is called as the simply supported beam with 2-point load of equal distance. If you take this beam, if you are able to draw the bending moment, the bending moment will be a maximum right at the point load which is of W into A, and the shear force is having a zero value in between the 2-point load. So this is called as the position of the beam between the 2-point load is called as the beam subjected to pure bending. So in the case of a pure bending equation,